Hey kids, welcome to section 4.6, solving polynomial equations. Today we're going to learn how to factor polynomials and how to solve polynomial equations by factoring. So first we need to talk about the rules of factoring polynomials. The very first one that you always look for is GCF. That's when you have a common number, common letter, or a combination of numbers and letters that you can factor out of a polynomial. The next one we want to talk about is difference of two squares. That's when you have two quantities. Both of them are perfect squares and they're separated by a minus sign. You can factor it into a plus b, a minus b. Doesn't matter which one comes first. Two new ones we're going to talk about today are the sum and difference of two cubes. They have these really ugly looking formulas over here. However, there's a lot of similarities. So if I have two cubes plus or minus two other cubes, I can factor them into the formulas that we have here, and we're going to do some of these later on. If you have three terms, you might have a perfect square trinomial. Now, we didn't memorize this rule per se. However, if we ever had something that came out as a plus b, we knew that we could put them together and put a quantity square on it. So that's what the perfect square trinomial means. Then we have general trinomials. We thought about this one as the guess and check method. That's where we had a value in front of the squared letter that we had then to use to factor. Then finally, a new one that we're going to talk about today is factor by grouping. Factor by grouping is useful when you have four or more terms and you essentially cut the problem in half and look for GCFs. We'll do some of these so you'll be able to see grouping as well. So the directions say to factor each polynomial. If the polynomial cannot be factored, write prime. So the first thing we always want to look at is there a GCF? In this situation, there is. You can take a 2 and an x out. That leaves you with 8x cubed plus 27y cubed. Now, 8x cubed is a perfect cube, and 27y cubed is a perfect cubed. So I'm going to just kind of go over here, and I'm going to say that this is 2x quantity cubed, 2 cubed and x cubed, and that the last one is 3y quantity cubed. Now you do have cubes. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and 5 cubed is 125. Those are kind of the first 5 perfect cubes. So what we're going to do now is we're going to let this 2x hang out. And then the formula, let's just write over here, x cubed plus y cubed is x plus y and x squared minus xy plus y squared. All right, so what we do is we take the cube root of the first thing, that's x. So the cube root of 8x cubed is 2x plus. Then we take the cube root of the second term, which is going to be this 3y. And then we're going, that's a weird looking 3, sorry. That just kind of sucked. All right, then we've got our parenthesis. We have the first term squared. So we want to take 2x, square it to get 4x squared. Then we have a minus, and we multiply the first and the second one. So minus, multiply the 2x and the 3y. So that's 6xy. And then we plus the second one squared. So plus 3y squared, which is 9y squared. And there's your factor. All right, let's take a look at another one. We have letter B, 5y cubed minus 320yz cubed. Looks like I can take a 5 and a y out. That leaves me with y to the third minus 64z to the third. Well, taking a look at what we have, the 5y is going to hang out. And then y cubed minus 64z cubed is the difference of two cubes. We can write that up here, x cubed minus y cubed. That's x minus y, x squared plus xy plus y squared. So I can look at y cubed as just y to the third. And I can think of the second one, 64z cubed, as 4z to the third. So the rule says I take the cube root of the first, which is y, minus and the cube root of the second, which is 4z. Then in the next one, I have the first one squared, so y squared, plus, and then I multiply the first and the second one, so I multiply the y and the 4z to get 4yz, plus, and I take the second one squared, so 4z squared is 16z to the second. And there's our factoring. All right, if we take a look at letter C, the first thing I notice is that there is a negative in the beginning, so I'm going to try to take a negative out. Looks like I can take a negative and a 2 and a w. That's going to leave me with 27w to the third plus 125z to the third. So I have the sum of two cubes. The first one is 3w quantity cubed, and the second one is 5z quantity cubed. So I can let the negative 2w hang out. The formula is the top one here, so I take the first one plus the second one. So 3w plus 5z. Then I take the first one squared. So 3w quantity squared is 9w squared. Minus, then I multiply the first and the second one together. So the 3w and the 5z, that gives me 15wz plus, and then the second one squared. So 5z quantity squared is 25z to the second. And there's my factor. All right, let's take a look at example 2. Factor each polynomial. If the polynomial cannot be factored, write prime. So when you have 6 terms, like we have here, we want to think factor by grouping. Factor by grouping is when you split the problem into halves and you try to find a GCF in each of the halves and see if what you have left over is the same. So if I take a look at the first half of the problem, I see there's an x in common. I can take out, so that leaves me with an x squared, a minus 8x, and a minus 64. If I look at the last half, it looks like there's a 4 in common. So I can take a 4 out, and that leaves me with 2x squared plus 3x plus 24. Well, the stuff in the parentheses is not the same. So that means that I need to do some rearranging so that I can try the problem again. So we're going to erase what we did. And I'm going to tell you the most often term that we move is the third term. Since this is a linear term, something x, I'm going to swap it with the other something x. So I'm going to put the plus 12x on this side, and I'm going to put the negative 64x on the other side. So all I did was swap the corresponding term. So now let's take a look. I can take an x out, and that leaves me with x squared minus 8x plus 12. And now I can take an 8 out, and that leaves me with x squared minus 8x plus 12. Oh, would you look at that? Take a look at the stuff in the parentheses, kids. It's the same. That's good. That means you did it right. So what we're going to do now is take what's in front of the parentheses, the x and the plus 8, and we're going to put it together, x plus 8. And then we're going to take the stuff in the parentheses that's the same, and we're going to write it one time, x squared minus 8x plus 12. Now we want to take a look at these parentheses and see if we're done. Well, if you have a square, you're probably not done. If you have an x to the first power, that one is probably done. So we're going to leave the first one, x plus 8. Now, I want to try to factor this quadratic. It has a coefficient of 1 in front of the squared letter, so that's the whole adds and multiplies thing. So I'm going to start my two empty parentheses. I'm going to put my x here and my x here. And I'm going to think of two numbers that multiply to get negative 8. No, add to get negative 8, multiply to get 12. Well, that's going to be negative 6 and negative 2. All my powers are gone. I've simplified it as much as I can. All right, letter B. Let's do the same thing. Let's chop this in half. Take a look at the first half and look for a GCF. It would be x squared. I have an x squared minus a 4x minus 4 left over. Then I take a look in the second half. I notice that this middle sign is negative. That means I'm going to take a negative out. And actually, that's the only thing I can take out. There's nothing else in common. So when I take that negative 1 out, look, nothing is the same in the parentheses. So that means we got to do some swapping. So let's erase this. And then let's take a look. We're going to swap that third term. Erase. We're going to swap the third term with its corresponding term on the other side, which in this case is the negative 5x squared. So I'm going to make this one be negative 5x squared, and I'm going to make this one be negative 4x squared. So all I did was swap those. So now we take a look at the first three terms, and you look for a common factor. That would be an x squared. You're left with x squared minus 4x minus 5. If you take a look at the last half, I notice that the first sign here is negative, so that means I'm going to take a negative out, and I could take a 4 as well. That's going to leave me with x squared minus 4x minus 5. Oh, would you look at that? The stuff in the parentheses is the same. That's good. So we're going to write this as x squared minus 4. We take the stuff in front of the parentheses and put it together. And then we're going to take the stuff that's written in the parentheses repeated. We're going to write it just once. X squared minus 4x minus 5. Okay, so they both have powers, which means they might be able to do more. If I look at this first quantity, x squared minus 4, that's the difference of two squares. So I can factor that as x minus 2 and x plus 2. Then the second parenthesis, x squared minus 4x minus 5. I notice this is a quadratic with a coefficient of 1 in front. So that's adds and multiplies. So I'm looking for an x and an x, two numbers that add to give you negative 4, multiply to get negative 5. Well, that would be negative 5 and positive 1. There's my factors. All right, letter C, let's chop it in half. Let's see, I've got a GCF in the first half of x squared. That leaves me with x squared plus 7x minus 4. GCF in the second half looks like a 2. That leaves me with 5x squared. Oh, right away I know I'm not going to have it. So let's erase. All right, so we're going to have to figure out what to swap. Well, almost always we're going to swap the third term. Let's swap it with the corresponding x squared term. So let's make this one a plus 10x squared and this one a minus 4x squared. So now let's see. If we look in the first half, I got an x squared. Take it out. I've got an x squared plus 7x plus 10 left. Then I notice the first sign here is negative, so I'm going to take a negative, and it looks like a 4. That leaves me with x squared plus 7x plus 10. Oh, look at that, it works. So now we take what's in front of the parentheses and put it together, x squared minus 4. And then I take a look at the stuff in the parentheses, and I write it one time, x squared plus 7x plus 10. Now they both have squares, which means I could probably do something. X squared minus 4 is the difference of two squares. So x minus 2, x plus 2. And the second quantity is a quadratic with a coefficient of 1. So I can do adds and multiplies. So I got x and I got x. Adds to give you 7, multiplies to give you 10. That'd be 2 and 5. Now if I wanted to, I could put the x plus 2's that I see double, and I could put it together as x plus 2 quantity squared, and then have the leftover x minus 2 and the leftover x plus 5. You don't have to, but that is another way you can do it. All right, letter D here. Let's chop it in half. Take out the GCF of the first. So that would be x squared. That leaves me with 2x squared minus 3x plus 12. Now I notice in the second half here that the order is not in the proper order. So I should have all the terms be going down in exponents and powers. So if I rearrange it a little bit and I take a look, it looks like all I can do is take out a negative. That's going to leave me with 5x squared plus 18x, and right away I can see it's not going to work. So let's erase and try again. Let's swap the third term, which is 12x squared, with its corresponding one on the other side, which is negative 5x squared. So I'm going to put the negative 5x squared here. And then I'm just going to rewrite this whole right side because I'm putting the 12x squared over here. I'm also using the minus 18x and the minus 30, and it's just easier. So if I take a look at the first three terms, I have an x squared in common. That leaves me with 2x squared minus 3x minus 5. If I take a look at the next half, it looks like I can take a 6 out. So plus 6. That leaves me with 2x squared minus 3x minus 5. Oh, good. The stuff in the parentheses fits. So now I grab the stuff that's in front, x squared and plus 6, and put it in a parenthesis. And then I put what's repeated once. All right, so now I see squares, so I think maybe I'm not done. I look at x squared plus 6, and I want to say it's the sum of two squares, but it's not. 6 is not a square. So x squared plus 6 is done. However, we can factor 2x squared minus 3x minus 5. I notice it's a quadratic. It does have a coefficient in front, so that means we're going to guess and check. So the first things in the parentheses are going to multiply to give you the first thing. So that's 2x and 1x. And then the last things in the parentheses multiply to give you the last thing. So I need to multiply to get negative 5. So we could try 5 and 1. I know that when I multiply them together, I get a negative. So that means there's one of each. So we can put a minus 5 and a plus 1. Don't forget to always check. So on the outside, 2x times 1 is 2x. On the inside, I get negative 5x. So 2x plus negative 5x, that works. That's negative 3x. All right, awesome. Okay, let's take a look at these. Let's see, I've got 1, 2, 3, 4, 5, 6 terms. So we're going to go ahead and slice this down the middle. So if I take a look at the first three terms here, it looks like there's an a cubed in common. If I take that out, I'm left with x squared minus 6x plus 9. If I look at the last three terms, it looks like there's a negative b cubed in common. If I take that out, I'm left with x squared minus 6x plus 9. Oh, that's awesome. All right, so we got a cubed minus b cubed. That's in the first parenthesis. And x squared minus 6x plus 9 goes in the second. Now, a cubed minus b cubed is an actual formula. It's a minus b, a squared plus ab plus b squared. And x squared minus 6x plus 9, I can try to factor. There's a coefficient of 1 in front of the squared letter, so I'm looking to add and multiply. That would be negative 3 and negative 3. I can put x minus 3 quantity squared if I wanted to. All right, if we take a look at letter B, I've got 6 terms. Let's chop it down the middle. GCF of the first three terms is x cubed. That leaves me with x squared plus 4x plus 4. If I take a look at the last terms, it looks like I can take a y cubed out. That leaves me with x squared plus 4x plus 4. Awesome. All right, so put what's in front of the parentheses together. X cubed plus y cubed, and write the repeated stuff once. All right, now x cubed plus y cubed is the sum of two cubes. That's x plus y, x squared minus xy plus y squared. And x squared minus 4x or plus 4x plus 4, that's a quadratic with a 1 in front, so I can add and multiply. They add to get 4, multiply to get 4, so that's a plus 2 and a plus 2. If I wanted to, I can write it as a quantity squared. All right, letter C. This is the difference of two cubes, or this is the difference of two squares. So this is x cubed squared minus y cubed squared. So now I can factor this as x cubed minus y cubed and x cubed plus y cubed. So I took and I wrote it as the difference of two squares, and then I factored it. Now each of these is the difference or the sum of two cubes. So if I do the difference of two cubes first, I get x minus y, x squared plus xy plus y squared. And if I do the sum of two cubes, that's x plus y, x squared minus xy plus y squared. And that's done. All right, if we do letter B, if I do what I did on the previous one for C, one would try to write this as a cubed squared plus b cubed squared. However, we don't have the sum of two squares. What we do have is the sum of two cubes. So I can write this as x squared cubed plus y squared. No, not x's and y's, a's and b's. I can write this as a squared cubed plus b squared cubed. So now I have the sum of two cubes. So I write the first one, a squared, plus the second one, b squared. And then I have the first one squared. So a squared squared would be a to the fourth, minus multiply the x and the y together, or the a squared b squared. So minus a squared b squared. And then we have plus the last one squared, or b to the fourth. There you go. Can't do anything else. Okay, number 4 is a word problem. A small cube is cut out of a larger cube. Determine the dimensions of the cubes. If the length of the smaller cube is 1/3 of the length of the larger cube, and the volume of the object is 3,250 cubic centimeters. Well, it says that the length of the smaller is 1/3 the length of the larger. So the length of the smaller y is 1/3 the length of the larger x. Now, I don't really want to have to deal with fractions, so I'm going to multiply both sides by 3, and I'm going to get 3y equals x. Okay, well, volume is length times width times height. So the volume of the entire cubed is x times x times x, or x cubed. And if I take out the smaller cubed, so minus y cubed, I'm supposed to be left with 3,250. Okay, well, let's replace the x with 3y. So this is 3y cubed minus y cubed equals 3,250. Well, 3y quantity cubed is 27y cubed. minus y cubed equals 3,250. If I subtract on the left, I get 26y cubed equals 3,250. If I divide everything by 26, I get y cubed equals 125. I cube root both sides, and I get y equals 5 centimeters. So if y is 5 centimeters, x is 3 times 5, or 15 centimeters. Okay, let's move on to solving. Solve equations in quadratic form. Okay, so in letter A, we're going to take a look at this, and first we notice that there are fourth powers, squared powers, and no powers. So if I think about this problem as like 4x squared minus 8x plus 3, we would factor using guess and check. We could try 2x and 2x. That's how you get 4x squared. And then I need to get 3. So like 3 and 1. And when I multiply, I get a positive. But when I collect like terms, I get a negative. That means they're both negative. So kids, check that. I get negative 2x on the outside, negative 6x on the inside. That gives me negative 8x. Okay, well, watch this, kids. Ready? I'm going to put a square here by the x. I'm going to put a square here by the x. Now 2x squared times 2x squared is 4x to the fourth. Outside gives us negative 2x squared. Inside gives us negative 6x squared. That's negative 8x squared. And I multiply to get 3. Well, once I have it factored, I can set each of them equal to 0. So 2x squared minus 3 equals 0, and 2x squared minus 1 equals 0. Now I have two equations that I need to solve. So I'm going to add 3 to this side. That gives me 2x squared equals 3. Divide both sides by 2. X squared equals 3 halves. Square root both sides. X equals plus or minus square root 3 halves. Well, kids, I can't find the decimal. That's not allowed. And I can't leave a root in the denominator. So this is like saying root 3 over root 2. Can't leave a root 2, so I'm going to multiply top and bottom by root 2. That's going to give me root 6 over root 4. So my x is going to be plus or minus root 6 over 2, because the square root of 4 is 2. Now I'm going to do the same thing to the second half. I'm going to add 1. 2x squared equals 1. Divide both sides by 2. X squared equals 1 half. Square root. X equals plus or minus root 1 over root 2. Can't leave a root in the denominator, so multiply top and bottom by root 2. So x equals plus or minus 1 times 2 is 2 on top. And root 2 times root 2 is root 4. And the square root of 4 is 2. So there's my 4 answers. And my original problem had a 4 as the degree. All right, letter B. We try to factor. It looks like there's a 2 in common though, so let's go ahead and take that out. So that leaves me with 4x to the fourth plus 5x squared minus 6 equals 0. Now I can try to factor. The first things have to multiply to give you the first thing. So maybe we try 4x and 1x. So 4x squared and 1x squared. Then the last things have to multiply to give you negative 6. So that can be 2 and 3 or 6 and 1. Let's try 2 and 3. And I for sure have to put the 2 in the parenthesis that doesn't have the 4, because I can't put anything in a parenthesis that has a like term or a greatest common factor. When I multiply them, I get a negative, so that means the signs are opposite. So let's put a plus with the 2 and a minus with the 3. So check it. On the outside, I get 8x squared. On the inside, I get negative 3x squared. So that gives me 5x 5x squared. Now I set each of them equal to 0. Now 2 equals 0 doesn't mean anything, so I can ignore that. If it doesn't have a letter, it doesn't have an answer. In the middle here, I'm going to add 3. So I get 4x squared equals 3. Divide both sides by 4. So x squared equals 3/4. Square root both sides. X equals plus or minus root 3 over root 4. And I can do the square root of 3. It's 2. So x equals plus or minus root 3 over 2. If I do the next one, I subtract 2. X squared equals -2. Square root. X equals plus or minus the square root of -2. Can't leave a square root in the negative in the square root. So I take the negative out as an I, and I leave the 2 as a root 2. Okay, then I look at number 5C, 18x to the 4th minus 21x squared plus 3. Okay, I'm thinking there's a 3 in common, and we're left with 6x to the 4th minus 4x squared, no, minus 7x squared plus 1 equals 0. Okay, so the 3 hangs out. I'm going to try to factor this. It has a coefficient in front, which means I'm going to do guess and check. Let's try 6x squared and 1x squared. And the last things have to multiply to give you 1, so that's only 1 and 1. When I multiply to positive, when I collect like terms, get a negative, so they're both negative. Now I can factor x squared minus 1 more. So I'm going to leave the 3, leave the 6x squared minus 1. Then I'm going to factor and get x minus 1, x plus 1 equals 0. Okay, so I set each of them equals 0. 3 equals 0. 6x squared minus 1 equals 0. X minus 1 equals 0. X plus 1 equals 0. Well, these last two are easy. I subtract 1 on both sides. I get -1. I add 1 on both sides. I get +1. This first one doesn't mean anything. It has no letter. So now I'm going to solve this last one. So I'm going to plus 1 and plus 1. 6x squared equals 1. Divide by 6. X squared equals 1/6. Square root both sides. X equals plus or minus 1 over root 6. Can't leave a root 6, so you multiply top and bottom by root 6. So x equals plus or minus root 6 over 6. There are my answers. Okay, last one. Looks like there's a 2 in common, so that leaves me with 4x to the 4th plus 6x squared plus 9 equals 0. Then I want to try to factor, but oh, guess what? This one doesn't factor. So guess what? We get to use the quadratic formula. Now notice that that middle term is x squared. That means I'm going to have x squared equals negative b, so -6, plus or minus the square root of 6 squared minus 4 times 9 all over 2 times 4. Quadratic formula. So this gives us -6 plus or minus the square root of -108 over 8. Can't leave a negative underneath the denominator, or underneath the radicals, so -6 plus or minus. Plus, I think 108 can be simplified. 108 is 36 and 3. So that's 6 root 3. So we have 6i root 3 over 8. Well, -6, 6, and 8 are all even, so I can divide by 2. X squared equals -3 plus or minus 3I root 3 over 4. And then I want x, so I square root it, plus or minus the square root of -3 plus or minus 3I root 3 over 4. And well, I can do the square root of 4. So plus or minus the square root of -3 plus or minus 3I root 3 all over 2. That is super ugly. All right, kids, that's the end of section 4.6. If you have any questions, please let me know. And as always, keep calm and keep trucking.